All right, here we go. This is the last page of the 5 point something. What are we on? 5.7? 5.7 notes. So I think early on in this unit, maybe I think it was 5.4 actually, we talked about this idea of a mid segment. And I told you, hey, the mid segment, the base and the mid segment itself are parallel. And the mid segment is always half of the base. What I'm going to do is I'm going to prove that to you. All right. So, in my mind, this is an honors type of question. So what we're going to do is we are going to prove this. And whenever you prove stuff in math, we don't want to use numbers. All right. We like to use variables because that shows us that it's going to work in any case. So, what do we know about mid segments? We know mid segments are parallel. I want to show it says it right here. How do we show things are parallel? Well, we use points. We use ordered pairs to show that the slopes are the same. So point O here, that is at the origin. So this is at 0, 0. All right, so we know that one. Now point M, what is the ordered pair on point M? M is a midpoint. All right, so what we have to do is we have to try to figure out what it is. All right, so we know we could say the x midpoint for M is going to be 0 plus B divided by 2. Right? The y midpoint is going to be 0 plus C divided by 2. Right, so I know that looks strange, but the ordered pair here is B over 2, comma, C over 2. All right, so whatever A and B are, that is, remember, we're plugging in numbers for these. All right, so whatever A and B are, it's just B over 2, C over 2. Now, point N, all right, the X midpoint for point N, we have to think about that. That is going to be B plus C over 2. All right, so whatever that is, right, is halfway between point B and point C. Nope, that's wrong. How about B and A? Sorry. Let me start over. I'm looking for the order pair for N, right? So I'm going to say the midpoint, or I'm going to use an N, I guess, is going to be B plus A divided by 2, right? And the Y midpoint is going to be C plus 0 over 2, right? So those are my two ordered pairs here. So we have B plus A over 2, and then I have C over 2. All right, those are the ordered pairs. Those are the coordinates for points M and N. All right, so if I want to show that MN is parallel to OA, we have to use slopes to do it. So the slope of OA, so I'm going to use the little m of OA, is equal to y2 minus y1. So we have 0 minus 0 all over x2 minus x1. So that's going to be A minus 0, which simplifies down to 0 over A, which of course is 0. So line segment OA has a slope of 0. Right? Now the slope of MN, use point M and use point N. All right, so we have C over 2 minus C over 2. All right, that's y2 minus y1. So I'm using point M and point N on this one. Divided by B plus A over 2 minus B over 2. All right. So that ends up being 0 on the top. And we have B plus A minus B all over 2. Now, if you notice, I could simplify the bottom a little bit more, but we have a 0 in the numerator. So that means 0 divided by anything, right? A and B are just some numbers, right? So 0 divided by some number is 0, right? So what we did is we showed the slope of OA, our base, is 0. The slope of MN, our midpoint, our mid segment, is also 0. So these two pieces of information right here show us that OA is parallel to MN. All right, so that's step one. Show that they're parallel. Now we have to show they are half as long. And to do that, we have to use the distance formula. So here's what I'm going to do. I'm going to take MN and I need to copy and paste them. Assuming my computer's going to work with me, and it's not. So why can I not drag it? All right, whatever. We have to use the distance formula. So that would be really great if my computer would cooperate here. Taking all of that and drag it down here. So there's point MN, and I need O and A. And so point O. That's at 0, 0. And I need point A. That is at A 0. All right. So I have to show that MN is half as long as OA. And to do that, I have to use the distance formula. So I'm going to start with OA. The length of OA is the square root of x2 minus x1. So we have A minus 0 squared plus y2 minus y1. So if we just simplify this, I'm left with the square root of A squared, right? Because the zeros go away. 0 minus 0 goes away. A minus 0 is just A. So the square root of something squared just leaves us with A. All right, so OA, segment OA has a length of A. All right, remember, A is just some number. It could be a 3, a 4, 20, whatever. All right, so now let's find the length of MN. MN is equal to the square root of x2 minus x1. So this one's going to look a little bit different. So I'll color code in this one. We have B plus A over 2 minus B over 2. All right, that's x2 minus x1. We take all that and we square it. Plus, we need y2, just c over 2, minus y1, which is also c over 2. Take that mess and we square it. All right, so let's go ahead and simplify all of this. If you look at this, I could write this as b plus a minus b all over 2. All right, anytime you have common denominators, you're allowed to make one single fraction out of it. All right, and what do you notice about those b's? I have a positive b and a negative b, so I'm left with a over 2. So what we have here is a over 2 squared. All right, if you look at this guy, I have c over 2 minus c over 2. That is 0. So that entire second term just goes away. So if I look at this square root of a over 2 squared, the square and the square root essentially knock each other out, and I'm left with a divided by 2. So what I just showed is MN is half of OA, right? If OA has a length of A, MN has a length of A divided by 2. All right, so what we did is we just proved that a midsegment is parallel to a base and it is half as long as the base, right? We show that for every single case. If you want to look back to 5.4 when we first introduced this, Um, this guy, right? We showed it for this specific triangle, right? So we showed it in just this one case, all right? We used like actual hard numbers for this one, right? So that is not a proof. That is just an example. If we look at this very last one we did, we didn't use any numbers. We used variables. B, C, A, those are all just any number. You could plug any number you want in there, and this is going to work for every single type of situation that involves a mid-segment, right? And that is really what a proof looks like. And, in my eyes, that is an honors geometry type of question, right? We are using variables and letters as opposed to constant numbers, all right? So again, you're not going to have one like that on your test, but I do think it's important for you to see something like that. And there is one like that in your homework. So yes, I would like for you to at least try the one in your homework. All right. So that's all I have. We'll see you in the next one.